Let's discuss a question from theory of machine. This is a very good question. Okay, so instead of directly putting a damper on a mass, there is sort of an amplification of the damper by means of a lever. Okay, so what we can do is, we will just approach in a traditional way. We'll first consider the mass, consider the free body diagram of the mass. Okay. Now this free body diagram of the mass, assume that at a point where x has a displacement of x and obviously a velocity of x dot. Okay, so displacement x and a velocity x dot. Now on this mass, obviously when you displace this by x, so there will be the spring will be opposing and the force of the spring is kx. Okay, and obviously at P, somehow the effect of damper will be felt. Like for example, if you consider this, when you try to move this by x, this Q will try to move to the right and the damper will try to oppose with the dampening force in this way. When the dampening force is towards the left at Q, then at P it will be such that the lever tries to the damper tries to pull Q towards the left, and obviously at P, so when this tries to move clockwise, P will be coming down and there will be effective force on mass M at the down. So that you can say that will be an amplification of the damping force. Okay, so the force that is coming here will be F, let's say FP. So let me just again make sure that you have understood the directions properly. What I mean to say is that when you try to move the mass x upwards, it has some velocity h dot. So when you're moving this upwards, basically you're trying to move P upwards, and Q has a tendency to move rightwards. So when Q has because of the lever, Q has a tendency to move rightwards. Basically Q has a tendency to move, Q has a velocity on the rightwards. Then the damper will apply a force F which is towards the left. Now this force F is acting on the Q at this side. So at P, there will be, in order to balance this, the dampening force at Q, there will be a force, the P will be applying on the mass in the downward direction. Okay, and that's what you get FP. Okay, so our main objective is to find FP because, like, okay, so if you balance this, because this is in a motion. This is in dynamic motion, so it has displacement x upwards, assuming that the velocity is x dot upwards and acceleration is x double dot. So applying Newton's third law in the Newton's second law in the upward direction. So the summation of all the forces in the upward direction should be equal to the mass into acceleration, which is mass into x dot. So Fy will be minus Fp minus Kx is equal to mx double dot. So if you bring everything to the one side, so mx double dot plus Fp plus Kx is equal to G. Now we need to find out what is Fp. Now coming to this can be found out like from the lever. Now coming to the fact that now I'm just drawing a line diagram of, so you have P here which is at a distance of A from O, and you have Q here which is at a distance of B. Okay, so now this point P has a velocity x dot upwards and the corresponding velocity, now obviously when P is moving upwards, Q will have a velocity something like this, KQ dot. Now how do x dot and KQ dot are related? Obviously the displacement at P, let me write in this direction, the xp, which is nothing but x. Okay, xp. Okay, so the lever will move by an angle, so xp is equal to r theta, which is a theta. Let's say the lever has moved anti-clockwise by angle theta. Okay, because of the mass, we are assuming that mass m is moving upwards, so P will move upwards and the entire lever will rotate by angle. So xp, or which is x, is a theta r theta, and q will be xq, which is nothing but b theta. So if you take the ratio, xp by xq will be a by b, and a similar ratio can be written for the velocities, because the time effect is just you have to, the time effect is the same for both. So h dot by xq is a by b. So h dot is the velocity of q, so the damping force that comes at q will be in the opposite direction which the damper will exert. This is c into always the damping force will be the damping coefficient into the relative velocity, and the relative velocity of the damper is, on one side it is grounded and the other side it's only xq, so the damping force will be in the reverse direction of the relative velocity. The relative velocity direction is rightwards because q has a velocity rightwards. So c xq dot, which is c into, from this equation it's b by a x dot. So from this equation, this is a very important equation. Okay, so once we got fq, now how is this force related? Now how is this fq related to fp? So again we can consider, because the lever, we assume that the lever doesn't have, because it's not given any inertia and all that, so lever is massless, so the moment about its fixed point will be 0. So fq is acting leftward, so fq into b will be producing a clockwise movement, and fp will be on the lever. It should be like this in order to balance this fq, because this q has a tendency to drive it clockwise. So fp on the lever exerted by the mass will be upwards, but on the mass exerted by the lever will be downwards, Newton's third law. So fq into p will have a tendency for driving it clockwise, and fp will resist, so minus fp into a. So this is a moment balance, so that we get the force at p. So fp basically from this is fq b by a, and fq we already got, which is c b by a from this. So ultimately it becomes c b by a whole square into h dot. Okay, now this equation we can just keep it here. So effectively this equation will become mh dot fp is c b by a whole square h dot. So so effectively your damping coefficient has been amplified because of the usage of lever, and that is b by a whole square. So the a term because we are asked to compare this equation with the standard equation, which is given as okay, the mass you can divide, I mean you can divide throughout with mass, so it will be c by m b by a whole square h dot plus k by m. So this is the equation we are asked to compare, and when comparing with this equation, there has to be plus here, there is some mistake here. Okay, that's a type of mistake. So a will be as you compare with this equation, a will be this entire term c by a, c by m, b by a whole square. This is your c by m. Okay, so B is the answer. This is a very good question. I mean, this is the max they can ask in theory of machine. Thank you.